Okay, here's a video I've created about how to simplify expressions involving radicals. My first example is if we have an expression such as 3 square roots of 2 plus 2 square roots of 2, wondering how can we add those? Well, because the value under the radical is the same, these are like terms. It's kind of the same idea as 3x plus 2x equals 5x. So in the same way, 3 square roots of 2 plus 2 square roots of 2, I can combine my like terms, and it's the same as 5 square roots of 2. Because the value under the radical is the same, you can combine those like terms into that. And let's look at another example, maybe a situation where they don't have the same number under the radical. If I have the example 3 square roots of 2 plus the square root of 32, now we see that our value under the radical is not the same. So I'm going to come over here to the right and I'm going to look at square root of 32. Let's look at this a little bit closer and see if we can figure out anything about it. If I simplify this radical, let's see, I know it's the same as 16 times 2. I know that 16 is the same thing as 4 times 4 times 2. And it looks like we're going to have a whole lot of 2's under this radical. That 2's there, that 4 breaks into 2 times 2, and that 4 breaks into 2 times 2. We know that anything we have 2 of, I can put one of them out in front, and now I've still got 1, 2 under my radical. So this actually is 4 square roots of 2 is what this is equal to. Well, if I now know this is 4 square roots of 2, I've rewritten square root of 32 as 4 square roots of 2, and now I can see that these in fact are like terms and I can add them. 3 of something plus 4 more of something is going to give us 7 of that something, of whatever that is. So I can see that if I were to add those, it's equal to 7 square roots of 2. Okay? Doesn't look like a 2. 7 square roots of 2, and like I said, we know that because we've simplified the second radical and we find out that it actually is like terms with our first radical. I've got one more example, and this is one where we will multiply, and that first one is kind of what you do if you're going to add or subtract 2 radicals. In this last one, we are going to multiply. Well, I've got 2 square roots of 6 times 5 square roots of 3. Well, we know that 2 square roots of 6 just means 2 times the square root of 6, and 5 square roots of 3 just means 5 times the square root of 3. So I can change the order of all this because of the commutative property. And I'm going to change it to 2 times 5 times the square root of 6 times the square root of 3. Now I've got my radicals together and my just integers together. So 2 times 5 is 10. And if I have 2 numbers under different radicals, that's the same as writing them under the same radical. Okay? So square root of 6 times square root of 3 is square root of 18. Now that we're here, we're not completely done yet because the square root of 18 simplifies, as we can now see. I know that the square root of 18 is the same as 6 times 3, or in other words, that 6 can become 2 times 3 times 3. And so anything there's 2 of, I can cross it out and put it out in front, and that becomes 3 square roots of 2. So if I were to rewrite square root of 18 as 3 square roots of 2, I end up with this. I still have my 10, and then square root of 18 becomes 3 square roots of 2. 10 times 3 is 30 square roots of 2. So if I were to start with this original expression and multiply, remember I can change the order to the commutative property, and we need to remember this property right here. Whenever I'm multiplying 2 values under radicals, I can rewrite them under the same radical, and that's kind of how we arrive at our final answer of 30 square roots of 2.